All right, so today is similar to what we did Thursday and Friday. So again, we're looking at these two-column proofs, except now we're using angle relationships instead of segment relationships. So it's the same, just with angles. So before we get started, I kind of want to review some how to find certain angles. So in this first one, we want to find x, okay, and the measure of each angle. So with these two angles, those two angles make a line, right? Okay, together they make that line PR. If two angles make up a line, then their measures have to add to 180. So if I have equations for angle 7, and angle 8, I can add those together and set it equal to 180. So we can take, we're quiet now please. We can take 5x plus 5 plus x minus 5 and set that equal to 180. Those two angles are considered a linear pair. Okay, they are two angles adjacent to each other that form a line. Okay, now I can combine like terms here. So I have 5x plus x is 6x. I have 5 minus 5, that's 0. So we have 6x equals 180. You'll divide both sides by 6. So x is 30. So if x is 30, what is the measure of angle 7?
155.
155 degrees.
I'm sorry, I take it off. I love you so.
Angle 8, plug in 30 for x. That would be 25 degrees. Okay, then you can make sure that they add to 180. So if I were to add those two, I would get 180. Okay, and number 2. Okay, number 2. In this one, we have 4 angles. Okay, we have 4 angles here. Now, again, all 4 of those angles make up a straight line. Okay, if your angles make up a straight line, they would have to add to what? 180. So I can add all 4 of those together and set it equal to 180. So we'll take 5x plus 4x plus 6 plus 10x plus 12x minus 12, and that has to equal 180. From here you want to combine like terms. If I add all the terms with an x, okay, you get 31x. Add all of your constants. I have 6 and minus 12 here. So minus 6 equals 180. Okay, add 6 to both sides. So we have 31x equals 186. Divide by 31. And x will be equal to 6. Okay, so for both numbers 1 and 2, you can add your angles all together to be equal to 180 since they form a straight line. Okay, now if I wanted to find all of those angle measures, we need to focus. If I wanted to find all of those angle measures, I'd plug 6 in for x for every single one of those angles. Okay? Looking at number 3. Okay, again, I want to solve for x. I'm given the measure of angle 11, that's this angle right here, is 11x. I'm also given the measure of angle 13, this angle right here, is 10x plus 12. So again, how can I figure out what x is? Set it to 180. So we have 11x plus 10x plus 12 is equal to 180. Okay, so we have 21x plus 12 equals 180. Subtract 12. I have 21x is equal to 168. That is an 8. Divide by 21. And you should get x is equal to 8. Now if I plug in 8 for x for the measure of angle 11, I would get 88 degrees, right? So what's the measure of angle 12? 88. Okay, why? What type of angles are those? Do you remember? Angles across from each other formed by two intersecting lines are what type of angles? Vertical angles. Okay, so that's the kind of stuff you need to look for in your pictures. Okay, so you'll need to be looking for vertical angles. Okay, you'll need to be looking for two angles that are a linear pair, so they add to 180. Those will be your freebies in your pictures when you go through your proofs. Okay, so you again need to be looking back at that picture as you go through your proof. Any questions on those top 3 problems? It's kind of a review from chapter 1. We worked with those types of angles. Okay, so next we want to move into our 2-column proof. So again, it's similar to what we did Thursday and Friday. Okay, with Thursday and Friday's proofs, we did it with segments.
Oh my gosh.
Now we're going to angles. So again, it's the same process. So again, I already have my picture drawn, so I don't need to draw it in. Next, I want to go to my given information. Okay, so I have angle QPS. That's this angle right here. Okay, is congruent to angle TPR. That's this angle right here. Okay, those two angles are congruent. So I have this one and that one. Okay, however you need to label it so you know that those two angles are congruent. Now we need to prove that angle QPR, so this one right here, the smaller angle, is congruent to angle TPS, this angle right here. Okay? So, thinking about your proof, I have these two larger angles congruent. Well, those two larger angles share this angle here. So I might be able to subtract that angle out somehow to get those two congruent. Okay? So again, make sure you're thinking about how you labeled your picture to help you go through your proof. So starting out here, again, our first statement is always our given. Okay? So we have angle QPS congruent to angle TPR. Okay, and your reason behind writing that statement, it was given to you. Okay, next, I'm going to use that given to move down a step. So if I go from congruent angles to equal measures, okay, I still have QPS and TPR. Okay, but now it's in this measure of angle form. So from congruent to equal measures. Do you remember which one that is?
Yes.
Definition of congruent angles. Okay, so same thing as we did with segments. When we changed from congruent segments to equal measures, We use definition of congruent segments. We'll do the same thing with angles. All right. Next one, letter C. So looking at what I was already given, I want to see how they got to this measure of angle QPS equals the measure of angle QPR plus the measure of angle RPS. Okay? Well, if I'm not quite sure how they got that from what my other steps were, again, you need to look at your picture.
Oh, I know. Is
Okay.
that the postulate one?
Yes.
Ha.
So you have angle QPS, okay, that's equal to angle QPR plus RPS. Well, if I add two smaller angles together, it equals the larger. Same thing with TPR. Okay, you add TPS plus RPS. Two smaller to get the larger. Okay, that is your angle addition postulate. Okay, just like we had segment addition postulate, you also have an angle addition postulate.
Is it more like substitution?
This one says substitution.
Oh, shoot. Well, I knew it.
Okay, so moving along here, somehow I need to substitute something to get my statement here. Okay, so I'm going to use what I had previously written down. So up here I have QPS equals TPR, right? Well, I have a QPS, don't I?
Yeah.
And it's equal to something else besides TPR, correct? And TPR is equal to something else. So can't I replace QPS from letter B with what it's equal to? Okay? And I can replace TPR with what it's equal to. Okay, so instead of QPS, I have the measure of angle QPR plus the measure of angle RPS. Okay, so taking this statement, replacing it for that QPS there. Now I'm going to take this statement and replace it for this TPR. Okay, so this is equal to the measure of angle TPS plus the measure of angle RPS. Okay, you see where I got that from? Yeah. All right, what I want you to notice from this side of your equal sign, this side of your equal sign. Both sides have the measure of angle RPS, right?
Yes.
And somehow I need to prove angle QPR is congruent to TPS. Well, right now I have QPR and TPS here. And if I have the same angle on both sides of that equal sign, what could I do?
Isn't it addition property
What is
equality or
this?
something like that? Or I don't know.
What?
No, it's just-
What? Did you even fill this out?
It's right there.
Why did you?
Subtraction.
You're supposed to sign
So
there,
equality.
aren't you?
Sure.
Well, everybody else signs
Addition.
there.
What if I subtract this angle?
Oh, I knew. Subtraction.
Yes. So I can subtract this angle from both sides of my equation. When I do that, I end up with the measure of angle QPR is equal to the measure of angle TPS. Now, if I subtract it from both sides of the equation, that is the subtraction property of equality. I just spelled that wrong. It's fine. Okay, now your last statement has to be what you were trying to prove. Okay, so that means I need to write angle QPR is congruent to angle TPS. Now if I'm switching from equal angles two congruent angles. Okay, that's the definition of congruent angles. You see how this is really similar to the segment ones that we did? It's just with angles instead. Okay, so you're doing that same process. Any questions on how I got my statements or my reasons?
You want the breakout space now?
No. All right, so number 2, we have to draw in a picture here. So I'm going to draw in your picture. I have a vertical line. I have points A and B on that line. I have a horizontal coming off of point B, a horizontal coming off of point A, I have point C and point D. And I'm going to connect those two. All right, so in our given, we have angle DAB and angle ABC are right angles. Okay, so I'm going to label those. Okay, so those two angles are right angles. I also have angle ABC is congruent to angle BCD. Well, if that angle is a right angle, what would that have to be? A right angle, since they're congruent. So I'm going to label that right away. Now what I have to prove is the measure of angle DAB, so this angle right here, is equal to the measure of angle BCD, so this angle right here. Okay, so those two angles there, we have to prove that they're equal. So starting off my proof, again, our first statement is our given. Okay. Next, moving from what we were given to our second statement. Okay, in this statement, I have angle DAB is congruent to ABC. From my given, those two angles are right here. Okay, it told me they were right angles. If they're both right angles, they would have to be congruent to each other, right? Do you remember which theorem that was? Right angle theorem. Okay, since they're both right angles, they'd have to be congruent. That is what the right angle theorem says. Okay, next, moving from statement 2 to 3, I want to see what changed. Well, angle ABC changed to angle BCD. Okay, I want to see why that changed. Well, if I look up here, I have angle ABC is congruent to BCD, so I replaced it for line 3. Okay, since I hadn't used that piece of the given yet, I still had to use it for that line 3, and yes, it is substitution. Okay, so I substituted angle BCD in for ABC. Okay, my last statement, again, has to be what I'm trying to prove. So that is the measure of angle DAB is equal to the measure of angle BCD.
I'm dying inside.
From 3 to 4, I have congruent angles, And then I have equal measures. Okay, which,
That's congruent angles.
yes. What?
She was really mad when you like say yes. No, not okay. Never mind. Yes.
Okay. Any questions on that second one there? Okay, that's another type of angle proof that you could get. All right, on the back. This one's a little bit longer. So you have your picture drawn over at the right here. We want to look at what we're given. So we have angle 1 is congruent to angle 5. I'm going to label that right away on my picture. Okay? Label those two angles congruent. Now, we want to prove angle 2 is supplementary to angle 5. Okay? Supplementary meaning they add to 180. Okay? Next, I want to look for some freebies in my picture here. So, if I look at angles 1 and 2, those are a linear pair, right? Okay, a linear pair adds to 180. That could be one of my freebies, okay, from the picture itself. Now, you won't use this, but you could also see angle 1 is congruent to angle 4 because those are vertical. Okay, those are just some of the things you should be looking for within your picture. So what I want to do now is start my proof. So my first statement, angle 1 congruent to angle 5 is given. Okay, now I want to see what changes from 1 to 2. Okay, I went from congruent angles to equal measures. Okay, when I do that, that is the definition of congruent angles. And please make sure you write angles and not segments, because we're working with angles, not segments. All right, from 2 to 3, okay, in statement 3, I have the measure of angle 2 equals the measure of angle 2. When I say something is equal to itself, do you remember which property that is? Nope. Reflexive. Okay, when I write out something is equal to itself, that is the reflexive property.
Is the next one angle addition postulate or addition equality?
Addition property of equality.
Yeah.
Okay, so the reason I'm stating this angle is equal to itself is because in number 4, I'm going from 2, where I said angle 1 is equal to angle 5, but I'm adding on the measure of angle 2 to both sides of that equation. Okay, so I had to state that that was equal to itself before I could add that on. Now, since I'm adding that to both sides of your equation, that is the addition property of equality. All right, next, from 4 to 5. In number 5, if you're not sure where they got that from, where are you supposed to look? At your picture. So in number 5, I have measure of angle 1 plus the measure of angle 2 is equal to 180. Well, both of those are adjacent, right? And they form a line. What's my reason behind saying they equal 180?
Supplementary.
They're a linear pair. It's the supplement theorem.
Oh. Yeah. You We're waiting for someone to finish it for us.
It is not the definition of supplementary angles. This is supplement theorem. Okay, supplement theorem is used when you have a linear pair shown. Okay? So I have this linear pair, so it must be the supplement theorem. Next, from 5 to 6. Okay? When I move to number 6 here, you could look at it a couple different ways. So, yes.
Yes.
So, I have the measure of angle 1 plus the measure of angle 2. Well, this measure of angle 1 plus the measure of angle 2 was up here. It was also equal to the measure of angle 5 plus the measure of angle 2. So I can replace that with measure of angle 5 plus measure of angle 2. Okay? Or, since in 4 and 5, both of these are equal to the measure of angle 1 plus the measure of angle 2. Okay? So they must equal each other in number 6. Okay? So I could say this is substitution. Or I could say this is transitive. Okay, now if I go from 6 to 7, in 7 I was trying to prove that angle 2 is supplementary to angle 5. Well, if 2 plus 5 is 180, wouldn't that mean they're supplementary?
Yep.
Do you remember my reason? If two angles add to 180?
Yes.
Definition of supplementary angles.
Is it raining outside?
I don't know. Okay, so again, these two right here are different. Okay, your supplement theorem is different from the definition of supplementary angles. Supplement theorem we use with a linear pair shown on our picture. Definition of supplementary angles is just two angles added together to be 180. And you can say then they are supplementary. Okay, do you have any, quiet please. Do you have any questions on how I did each of those steps? Okay, I have one more. Okay, one more, number 4. Again, the picture's already drawn in for us. So next step is to look at your given. So in your given, you have angle 1 and angle 2. And angle 1 and angle 3 are linear pairs. Okay, so angle 1 and 2 here are a linear pair, meaning I can add them together to be 180. And angle 1 and angle 3 are also a linear pair, so I can add those to be 180. Now what I want to do is prove that angle 2 is congruent to angle 3. Now yes, those are vertical angles, so you could say that they are congruent. But what you want to do is use your given to prove that they're congruent. Okay, so we're going to use the information that we were given in order to prove those congruent.
So why do you keep saying given?
Because you have to use the given information.
Yeah, but why are you saying that like louder than I do?
Okay, I don't know, Kenzie.
Given.
Relax. So, in number 1, again, I rewrote that given information. Now I want to use what I had as my given information to do number 2. Okay, well 1 and 2 were a linear pair. Since they're a linear pair, I could add them together to be 180. Same thing with 1 and 3. They're a linear pair, so they must add to be 180.
Okay.
So since they are a linear pair and adding to 180, that is the supplement theorem. Okay, not definition of supplementary angles. Okay, it said they were a linear pair, so it must be the supplement theorem. Now looking at number 3, I want to use my information in number 2 to do number 3, since I've already used all of that given information. Well, both of these right here, right, equal 180. Since both of those statements equal 180, they must equal each other. Okay? Or I could replace this 180 right here with this measure of angle 1 plus the measure of angle 3. Okay? So you're substituting this statement in for 180 since that's what it was equal to. Okay, so I could say this is substitution, or this is the transitive property. Okay, so I just used this information from 2 to get to 3. Now I want to use my information in 3 to get to 4, since I've used all of this stuff already to get here. So since both sides have this measure of angle 1, and somehow I got to the measure of angle 2 equals the measure of angle 3, well, I just subtracted the measure of angle 1 from both sides of that equation. Okay, when I subtract something from both sides of an equation, that's the subtraction property of equality.
There's the next one, definition of congruent angles.
Yes.
Alright.
So from 4 to 5, I changed from equal measures to congruent angles. When I do that, that is the definition of congruent angles. So again, just like with segments, these proofs are very similar. So you're using the information you had already written down to do that next step. You need to use every piece of your given information and every piece of your statements before that last statement to get there. Okay, so you need to use every single piece of that information. Any questions? All right, then please get started on